There we go. Can you guys see that?
Yep.
We can see that.
Okay, awesome. I'm using a high-res monitor, so if I can't see something, just holler and I'll zoom in as best I can. Okay, well, thanks you all for coming. Today I'm going to be going over the data mining and machine learning software called Orange. I'm going over a simple project end to end that will be focused around class imbalance, which you'll learn what that is, multi-layer perceptrons, neural networks, how to test multiple algorithms, and some visualizations. So without further ado, how Orange works is they have these little visual widgets that perform different tasks like CSV import. I'm going to use that to bring in the admissions file, which I have in my history, ironically. So once you have that loaded, what you can do, which is pretty cool, is you can go to the import options and you can tell Orange what type of data type each column is. Mine's already pre-populated because I did this earlier when I was testing, but you don't have to do it for every single one. But the ones that you do need for this data set is you need, let me make this a little bigger. I wonder if they'll let me, nah, that's annoying. Anyway, the university, research, and admissions need to be what's called categorical, which basically means, they have a set number of values. Like from this, I think universities from like 1 to 4 or 5 or something like that. And so they have a categorical meaning. And the other ones are just numerical, continuous values. So I'll give you a moment to kind of adjust your columns and types. Oh, yeah. And if I am going too fast, just let me know, or too slow, and I can speed up. And if you have any questions, feel free to chat or chime in. Jeanette, if you can keep an eye on the chat or somebody and field
Yeah, I can do
those. Okay, that'd be great. I hate for someone to get lost during a live demo. It's horrible because then you can't catch up and it's just, yeah, it's not pretty. Okay.
Wait, all right, I'm confused. How do I get into this mode? I have the CSV import thing, but I don't know how to get into it.
I hear someone talking.
Yeah, can you hear me?
Alex, I couldn't really hear your mic towards the end of your sentence. You got real quiet.
It's really quiet. Hello.
But I think what you were going at is that you didn't know how to open up that little screen he had in. So you'd start like a new Orange project, and then on the left side, you see how it has the CSV file import. You'd bring that into the right side panel where your project is, and then you can double click on that CSV file import, and it brings up that little window. And from there, you choose the file you want to import. And I think you have to wait for the import options to load, and after that, you're able to see that screen.
Or you can import any file from here.
Okay.
Yeah, that's a duplicate, don't need that. And yeah, once you have it's loaded, it tells you some info about the file. And in the import options is where I mentioned you can adjust what the column types are. And this is very key when you're feeding in information to your machine learning algorithm, which I will show the difference. Hopefully I remember when I get there how to show the difference. So I'll hang tight for a moment once again. Make sure everyone's at the same place.
Mine doesn't have the colors. Does that matter? The red and green.
Yeah, it doesn't matter as long as it says like N for numerical, C for categorical. I'm surprised you don't have the colors.
You can click on the rows, and then go to column type, and then find numerical or categorical for each of the columns to get the colors. So like click on
Oh,
the
so auto.
column
Yeah, I
number
have
one.
the auto one.
Yeah.
Yeah, the default is auto, which if you know something is numerical or categorical, you definitely want to manually set that. So Orange knows how to handle it. I'm sorry?
The column 3, 7, and 8 are categorical, and all of the other are numerical.
Yeah.
Yeah, I fixed it. Thank you.
Okay. Are we good to go? Okay, I'm seeing a shaking head, couple shaking heads. Okay. Go ahead and close the widget here. Now, one thing that's nice, the kind of the concept behind Orange, you can drag and click and connect these different visual widgets. So what I'm going to show you is distributions. And this is really nice because it gives you an idea what's going on with your data. And so you can look at the different distributions of every single column variable. And one that we want to specifically look at is what we want to predict. So what the data we're working with is scores from 400 students that are trying to get admission into a university. And so there's different columns representing different features of the data. So that's what all of these values are: the GRE score, the TOE, FL score, and so on. And so what we want to predict is if they will get admitted into university based off of these features. And so we look at admission, and one thing we notice is, let's see here, about 8% do not get in and 91% do. This is what's called the ground truth. You know that for these instances, which are, we know for all 400, who gets in and who does not. But what we see here is what's called a class imbalance, where you have significantly more values in one prediction class than another, because there are two classes we're trying to predict, where you make it or you don't into the university. And I'll show you a couple different ways that you can handle situations like this, specifically in Orange. Okay, so what we want to do is we want to select the variable that we want to predict, which I mentioned was that admission variable. So we can do select columns. Okay, it's already pre-populated for me. Ooh. But what you want to do is everything that's on the right is Orange considers this is a feature I want to pay attention to. If there are any features you do not want to include, you move it to the left. And originally, for you guys, when you load up the data, admission is going to be part of the feature set. And you want to move that down to be a target variable. So I'll hold off for a moment. So everyone can get this set up.
Is my target variable supposed to be preset like that?
What do you mean?
My admission is up with the others. Is that?
Yes. Originally, your admission will start in the set of all features.
Oh, okay.
And what you want to do is you select admission, you press the left arrow, and it puts this into a place called, it's like a holding bin called available variables, which orange does not pay attention to anything in this column. So if you want to exclude features from the learning algorithm, which I'll show how that can change things, this is where you put it. But we need to have a target variable to predict on, because we're predicting whether someone gets admitted into a university or not. And so we want to click that over to target variable. Okay, are we good to move on? Okay, excellent. Okay, so what we want to show you is how to visualize this data, which is high dimensional, has like 7 dimensions, and a plot called t-SNE, which is like PCA, principal component analysis. It takes high dimensional data and it projects it onto a 2D plot. So you can kind of get an idea of how things are similar with they're closer together. And if they're further apart, they're more, less similar. And my very fast laptop is crunching away. And this will give us an idea of the type of, oops, I opened it up. Where the data points lie with given features for given this projection. And you can see there's some clusters of red and there's a few dots of blue, which is because of the class imbalance. And we'll show how to adjust that. So I just want to show this is how you can get an initial view of your data and any type of clustering to see if the classes are separable or not. And I'll show you what this looks like when we perform oversampling or undersampling and how that can affect the separability of the classes for classification. And oversampling and undersampling are techniques used to, excuse me, to deal with class imbalance, which we showed earlier that there was a class imbalance. And so first, what we can do, you can actually do some Python scripting inside of Orange, which is really nice. So I'm going to write a little script. I'll paste this text, the code into the chat box. So you don't have to sit there and type it all out. So let me go ahead and get that to you guys, to you all. Copy. See if it'll get me to the chat box. Chat. There we go.
If not, you can just post in the Discord as well.
There we go. Open up my widget. I have it pre-populated because I worked with this earlier. So it has a little script, which I pasted into the chat. And last time I did this in the chat, the copy and paste worked fine. for putting it back into this Python script widget. If it
It
doesn't,
works fine. It works fine this time as well.
okay. Now, one thing that we want to do, this is showing you how to handle packages in Orange. This IMB Learn does not come with Orange proper. You need to install it. And so what you can do is go up to the options menu and click add-ons and do add more. IMB Learn. And actually it's already installed for me, but it'll ask you to install it. You hit yes. It will install, and you will need, I believe you'll need to restart Orange for that to work.
What
So
does it say? It's hard to see on the screen.
Okay, let me adjust the resolution. Because like I said, I'm working on a 4K display.
Yeah, some of the writing is a bit small.
Yeah, let me see here. Is that better?
Yeah, I think so.
Yeah, if it's not, I can change it again. Let's see, options, add-ons. There we go. Is that easier to see?
Yeah, thank you.
Awesome. Thank you for stopping me because I wasn't quite sure because the resolution I was working at.
This is much better.
I'm sorry, what add-on do I need to add?
That's okay. It's IMB Learn. So if you look at the script itself, oops, cancel. It's this guy right here from IMB Learn. It's a library that we will be using for calculating some things for the undersampling. And like I said, once it's installed, it probably will ask you to restart Orange. It does that for every package that you install. And there are so many different packages. Like if, for example, for natural language processing, there's text mining and textable packages that you can use. It's pretty cool. And there's a whole bunch of ones. There's a geo one, time series. Yeah, been pretty impressed with the software. Okay. Wait a second so people can get that up and get the Python script in the widget. Okay, we good to go?
I have an error.
Yeah.
It says attribute error cluster centroids object has no attribute fit sample.
Okay, do you have your select columns that looks like this, where you have your target variable?
Yes, in the missions, yes.
Okay, can you paste the error in the chat so I can take a look, see?
Yeah, sure thing.
Yeah, I also got an error.
Object has no sample. That's a new one.
I didn't get that error, but I got a
You got different errors.
yeah.
Let's see here. Do some on the fly Googling. Working on a different monitor right now.
Also, when I did the PCA, I didn't get the same like picture, I guess.
Oh, it's
Maybe I
they
did
do have a
something.
PCA, but I use a t-SNE, t.SNE, t/-SNE.
Okay.
It does a similar thing conceptually. Did you, when you installed IMB Learn, did you restart Orange?
I did, yeah. Though the install did fail the first time. I had to install it again and then it restarted. So maybe that helps. I don't know.
Hmm.
That's what mine says.
Okay. What
Oh yeah, that's the error I had the first time.
Yeah, I didn't restart because I don't
Anthony,
know
I
if it
think
downloaded.
I think you don't have Python installed on your computer.
Oh yeah, no, I don't have I don't have Python. I'm
Oh
doing
yeah,
C++
if you don't have
right now.
Python installed, that's definitely not going to work.
I did not know that.
No, that's okay. This is how you learn.
Okay.
Yeah, so I'm running on a Mac which has Python installed by default. If you're running on Windows, you have to do it explicitly. So if you're having trouble with that because you don't have Python, I will be sharing this Orange file after this presentation so you can run it yourself and see. You can work on installing Python while listening if you'd like, or just wait until later. Is that seem like covering the errors that we're seeing?
No, I got the same error as Alex, and I'm also running a Mac with like Mac Python installed already.
Yeah, I have Python installed as well.
Okay. You're getting the let me get my chat window back up. You're getting the cluster centroids object error.
Do one of you want to share your screen?
Yeah. I can share my screen.
Okay, let me stop sharing for a second.
Can you guys see my screen?
Yeah.
So when I run this code, this is the error that I'm getting.
Go to your packages, the options menu add-ons.
Options. Oh wait, let me share my entire screen because I don't think you can see this.
Wait, what? That's strange.
I guess what I was wanting to see what was installed.
Yeah.
I mean, you can, if it's installed properly, you should be able to search for it in the filter.
Can you guys see this now?
Yeah. Okay, yeah, it's not installed. So you need to go to the add more.
That's strange.
Yeah.
I have the same
Yeah,
thing.
then
Yeah.
click OK.
It just shut the window for some reason. Let me try again. It says that I have installed here because if I click somewhere over here, it's gonna give me like this install pop-up,
Yeah.
but it's not giving me over here.
Did you restart Orange?
Yeah, it automatically restarted Orange. Let me do reset widget settings and see what happens.
Probably as administrator.
Yeah, Lexi just said in the chat he was able to resolve the error by running orange as an administrator.
Oh, okay.
Okay, so it works as an admin.
Perfect. Thank you.
Okay. You want me to go ahead and share my screen again?
Yeah, you can go ahead.
Okay, can you see that all right?
Uh-huh.
Okay. Yeah, one thing when you're in these Python widgets is make sure you click on the script name and click on run. Otherwise, nothing will happen. That's something in the documentation they make sure you know, because so often you write stuff and you're like, why isn't it working? Well, you have to run it. So I went ahead and renamed this Python widget undersample so I remember what it does. And you can look through the code later. I'm not going to step through it because it uses some specific orange data structures, which I'm still understanding how they work. So I wouldn't worry about the in-depths of the code right now. And so you can do the same thing with the distributions and look at the admission feature and they're both equal. So we have 33 over here and 33 over here. And I'll show you what the clustering looks like now that we have done undersampling. And there, it's a lot more separable. You have blues on the bottom left and reds on the top right. So the undersampling helped kind of segment the feature space. So you can run classification and get better results, better accuracy and whatnot. Okay. Now in machine learning, you do a train test set where you take a certain percentage of the data, you train on it, then you test on another percentage of the data called the test set. And that can be, thankfully, simply done in orange by using what's called a data sampler. And it defaults to using 70% of the data for training and the other remaining 30% as test. And so now you can start setting up classifiers. So we're going to start with, I talked about neural networks. And the default neural network has default 10 units in a hidden layer and uses the activation ReLU, which is one of the best ones. I'll show an example of how to compare another one, which is like logistic, which is another one that's used, and the differences in classification. And if you hear anything interesting in the background, that's my kids. Just to let you know, I can hear my son right now. Okay. So we can connect the neural network to predictions. And then simply go from data sampler to predictions. And we say the remaining data, which is that 30%, you send. And so what's nice about Orange is on the little connecting lines between the widgets, it tells you the type of data and transformations that are going on. So for example, from the data sampler to neural network, it says it's going a sample to data, and then the remaining data to the predictions. And what we can see when we open predictions, we only have one classifier. You see that the neural network has a classification accuracy of 0.895, which is pretty good. And so how to read the output here, I'm not going to go through right now since we're getting a little, I'm watching the time here, but that's something you can look through yourself later, because I want to make sure we get through the whole process end to end. One thing I want to make sure I know about this network is it uses 10 nodes as a hidden layer, because I'm going to show what a different network does. And this other network, I'm going to do 2 hidden, 4 hidden, and 2. So 3 different hidden layers. And you divide them, you separate them by commas. And I'm going to use a logistic activation function. And let me make sure. Two, 4, 2. If we look at the predictions, the bottom, unfortunately, it doesn't tell you the different networks when you're using the same classifiers. It's kind of annoying. But since I know what the first one was, the 89.5, you see at the second one is really low at 47. And that's actually because of the using logistic for the activation function. Is if I change that from logistic to ReLU, we get that, oh, the classification still stays at 47. That's really funny. So it just might be the network. That can show you that the network architecture has some problems. And so you can play around and adjust it from there. And so it's really easy in Orange to adjust these things. So it's like, okay, this doesn't work. Let me just try 4 and see what happens. Ah, 94.7. That's much better architecture. And you can add, as many of these classifiers as you want. Like a very classic one is logistic regression. And it does decent, pretty well, it does 94.7. And there's a whole bunch of different types of models that you can use. On the left of the window, you can see the tab that says model. You can click on that and you can see all of these models that are in here. There's KNNs, linear regression, SVMs, random forests, AdaBoost, pretty famous one. So very useful.
Sorry to just stop you, but I think Max asked a question about validation data. in the chat.
About what?
About testing and verification, the data used in testing and verification, and is it randomly selected?
Oh, the data sampler?
Yeah.
It is randomly sampled.
Also, Christian, I noticed that as you mentioned in the predictions, it didn't change the name of the different models. If you double click on one of like the neural networks, for instance, at the top, there should be like the name field, which it isn't. I don't know why it doesn't automatically like update with the graphical one, but
Oh, that's
I was
really
gonna say,
annoying. Hey, look at that. Learn something new
Yeah.
every day.
yeah,
Thank you.
yeah.
Yep, I am still even learning things about this program because there's so much to learn. My supervisor gave a presentation at Orange for a prediction class for sparse data the other day, and I learned a whole bunch just listening to him doing that other classification problem. It was really cool. Okay, now we've done undersampling. Now, what if we wanted, there's this other thing called oversampling. Let's see here. It's another Python script. Let me open it up. Let's see here and paste the code into the chat. There we go. It uses an algorithm called SMOTE. Let me open mine up. Let's see. Yeah, it uses an algorithm called SMOTE to actually generate new data points based on the features. And so I think it uses a certain kind of distribution to do that. And I'll show you what visually kind of what it looks like. So if we once again look at the distributions, you see now we have 50% of each again, and there's 367 of each. And so if we look at the original distribution of the data on the left, there's 367 positive, number one cases. And so basically the oversampling generates the case of class 0 up to that certain number of class 1s and vice versa. I noticed that when I was playing with this before. Okay. So let's take a look at the t-SNE. Takes a moment, some more data points in there. On my incredibly fast laptop. Oops. Now we get this very interesting clustered region, which you can see is fairly separable with a few exceptions. Separable and with respect to being able to classify correctly. And this space is not linearly separable. So we're probably going to need something like a neural network to be able to fit this type of space. And so one thing you might notice is I'm mirroring what we did for the undersampling. So that kind of is nice because you can, it's basically copying. So now we're doing a data sample. Once again, and if you really want to and you're lazy, you can select those nodes, copy, and paste. And that's pretty cool. And you can just connect the dots. Just the one, let's see, need to run the code. Oops, I connected to the distributions. This is really good opportunity, because if you double click on, as I did earlier, any of the lines, it gives you this, you can edit the links. And I made an accidental link. So I just click on it to erase it. I really want the data to come from my Python script. There we go, now it works. Move this down a little bit, yeah. Let me change this back to a 242. Change the name so we can tell which one it is. And we double click on predictions. And we can see that the network had 10 nodes per hidden layer, for one hidden layer, performed in this case at almost 94%, and the other one about 50%. And so what I've done before, which seemed to have worked, oh, it's on ReLU too, huh? Yeah, normally ReLU does pretty well, but it must be the architecture of this neural network that is not working. And that's what's the beauty of Orange, is you can play with it, like I showed earlier. And so let's see here. Yes, since we have a little bit of time, the last thing I wanted to show is that can make a huge change in what you're doing, is choosing what features you actually use for the learning algorithms. So one thing I did earlier today, just playing around, is I took the university rating and I removed it from the feature set, so it would not be used. And the results actually were pretty different. So I'll show you what that looks like. And it's interesting, you know, when I made that change, it then cascades down the full diagram. You can see this t-SNE is running, and then after that, you know, this red dot's going to run, and then these red dots are going to run. There we go, the whole thing's run through. So if I look at the t-SNE of that data, it's no longer these little blobs here and there. It's two complete different clusters that are the same class. And it looks like this because we have a class imbalance. Like I said, once we fix the class imbalance, oops, wrong widget. We get a more separable space. And this clustering looks different than the other one before. And if you can't remember, that's okay. We go to the predictions, we can see differences. Like we're now up to 96% accuracy. Oops, sorry, we're down 90%. Oops, looking at the wrong one. So that adjusted the accuracy. And so this is, you can select your features based on what you think will have the biggest impact. So what I mean by that is, what do these features actually mean to your data? Are they beneficial or not? And if you think they are, you leave them in. If not, pull them out and see how the classification works. And one of the things, if I remember correctly, yeah, this t-SNE was interesting because it became very, very separable, very well, when I removed that feature from the selected features to use. And that is reflected in the predictions, where you then get a prediction of 100%. And even the neural network that was ill-formed went up to 68 instead of being about 48 or 49 or something. Now, of course, when you get an accuracy of 100%, you need to look at different things because you might be overfitting. That's a different lesson. And so this is, this is what I have planned for today, where we have an end-to-end machine learning process to take some data and try to perform some classification predictions on it. And yeah, and you can add, like I said, as many models as you want. Now let's try the SVM, oops, which is a popular one. And if we look at prediction of SVM, it does okay, 79. But yeah, you can just play around with this. There's loads of documentation. There's a whole bunch of YouTube tutorials. If you look at the bottom left, it says select a widget. And if I hover over, let me find a good one. Normally they have a little, it's not showing me. Normally they have a little info you can jump to. But you can also, there's workflow examples. And so, like I said, if you search, if you want to do, prediction orange software, it shows you how to do these, a simple flow chart for, given some built-in data set that comes with the software. So anyway, I'm going to stop rambling here and take any questions.
I have a question, Chreston. Have you used this at all within your research? Do you use it more for like playing with it on the side?
No, I've actually used it for my research. I've used it for looking at distributions of sentiment in tweets.
Okay.
And I've been using mainly the visualizations to kind of get an idea of what's going on in my data before I do anything more advanced. But my supervisor in like I said, he had a presentation the other day. We had sparse data that he was able to use in order to predict a certain outcome. And I don't want to go into detail of the data because it's a little bit sensitive. But it was basically the idea behind it, and also all machine learning is, what do you want to predict? And how do you formulate your data to help with that, get to that prediction? What features do you want to use? What algorithms best fit? Some algorithms work better when the data distributions are Gaussian, or some not Gaussian. So that's topics for another day kind of thing. But yeah, so I do use it. I haven't used it too heavy yet, but it can be. Like I've seen it used very heavy. So.
Interesting. Thank you. Does anybody else have any questions?
Will this be uploaded later with the code? Because my Python took too long to install.
Yeah,
so I
for
got
sure.
lost.
Yeah, we'll get this video out there, and we'll also send the code out as well in the follow-up email or the Discord. We'll put in the Discord as well. But yeah, for sure. And if we don't get it out, then you can always email anybody on the executive board, and we can get that to you as well.
Thank you, because Python took too long.
That's too bad. But yeah, and once you get that Python installed, you should be able to open up this file that we share and load the data and just run it.
Yeah, this looks very interesting. I might take a extra time to look at it.
Yeah, I've been in my projects, I've been exploring and playing around with it more. And let's see here. Yeah, I've played around with sentiment analysis in here, and you can connect, like this is text mining. You can connect to Twitter and pull Twitter data live using search terms. It's kind of cool.
That sounds very cool.
Yeah, it has connections to like the New York Times, PubMed.
Yeah, that is pretty crazy. That's built in.
Yeah, I've been pretty impressed with this. And there's plenty of visualization algorithms that they have. Oops. And they have this educational package, which shows you how some of the classic like beginning learning, machine learning algorithms work. Like how does gradient descent work? It shows you. How does k-means work? It gives you an interactive way to play with it. So and they have polynomial regression, classification, regression. So this has been in the works for a long time. It's been, I've seen it even like 3 or 4 years ago. I remember seeing it as an option when I was installing another piece of software. So it's been around for quite some time. And it's open source software. So as you can see, it's a very well developed open source piece of software, which is really cool to see.
Yeah, for sure. But yeah, I guess if nobody has any other questions, then you guys are free to go. Also, I did see Alexi in the chat said that the fixed sample issue that was brought up earlier can be resolved by changing the method name to fit resample.
Okay, awesome. I think I saw that when I was searching in Google, but I wasn't quite sure if that actually would solve it or not. So I'm really glad to hear that.
That is an interesting error, though. I don't know why it would be different for different.
Yeah, I mean, when you actually do the add more in the options menu, what it is doing underneath is using pip install. And for those who don't know what that is, pip is the package manager for Python. So it's doing command line stuff for you.
Yeah.
So do we need to do anything extra with Python, or do we just install it and it should compatible? Do we need to like instantiate anything within Python, or just within Orange?
Within Orange, I do not believe so. You might have to install things like if you look at the top of the code that I pasted, it has different libraries that are imported. There's one called NumPy, N-U-M-P-Y, a numerical Python. You might need to install that. I'm not sure that Orange might come with it pre-installed. You might be able to use the package manager that they have within Orange to install it also. So you don't have to deal with command line stuff.
Yeah, I don't think there should be an issue, but if you do run an issue, you can reach out to me. I wouldn't even mind having like a one-on-one on Zoom so we can get you set up. But
Yeah,
Or
this
Discord.
yeah,
Or
this would
Discord if
be,
that's easier.
yeah. And like I said, this is like awesome software to play around with and learn machine learning from. And the authors have a whole bunch of tutorials that show you how to do different types of machine learning problems. So it's pretty cool.